We're pleased to have Perry Green with SJI here to give this presentation. SEA and SJI from really the early years of SEA has had a good relationship with SJI. It's partnering in a lot of things. We've had input in their direction publications, and been a lot of good interaction between the two groups. Perry is technical director for SJI. He's been that since 2004. He was previously assistant professor at the University of Florida in Gainesville. He's earned his Bachelor of Science degree from Columbia University in 1977, Master of Civil Engineering from Lehigh in 1979, and PhD from Lehigh in 2000. Welcome, Perry.
Thank you, Eddie.
Looking forward to your presentation.
Good morning. We're going to talk a little bit about safe handling and erection of steel joists and joist girders. And we're going to go through a little bit of a history. It's a new laptop. Hopefully everything works really well. I was in my office at 10 o'clock last night making sure some of the better parts of it did work. Going to talk a little bit about construction and erection safety, some of the regulations, the Code of Federal Regulations, CFR 1926, subpart R, which deals directly with steel joist erection, but it should be prefaced with, and it is prefaced with the word, it's safety standards for steel erection, okay? And the key in what OSHA did was to ensure for you folks that when you are erecting structural steel joists, that they are done in a safe manner. What we've done, and in some ways in partnering and having a review of our latest publication, which is Technical Digest number 9, Handling and Erection of Steel Joists and Joist Girders. We're actually up to the 3rd edition now, even though everybody keeps looking for the 2nd edition. We are now keeping that document current with our specifications and the work that SJI is doing. And we'll talk about that as we go along. In subpart R, steel erection, some of this I'll go fairly quickly through. These are the breakdown from 1926, 750 through 757. And so our little part of the world is 1926, 757, open web steel joists, and that's what I'm going to concentrate on. If you do both joists and structural, you should be familiar with some of these other things that are on the list. A little bit about the OSHA history, just to fill you in for the younger folks and the older folks. I think Eddie sat through all of this. In developing what came about in 2001, actually it started back in 1984. It takes the government a long time to do some things that should be like the guy on the walkie-talkie, it's done, we should be able to get it done. But in 1984, there were the first talk about draft proposal to revise the rules for steel erection, and that included open web steel joists. 4 years passed, and then they finally announced this intention to regulate steel erection. In 1990 was a first request for negotiated rulemaking was made within the government. In 1991 they realized they couldn't do it themselves, so they had to hire an outside consultant, and it goes on and on. 1992 they published a notice of intent to establish this negotiated rulemaking. 1994 is really the work got started, so 10 years already passed before they really got down to anything. And they formed this group called CENRAC, which was Steel Erection Negotiated Rulemaking Committee, okay? And what it was all the stakeholders were involved in this. And I actually think SJI was late as one of the stakeholders involved in the rulemaking for the new safety standards. And that committee met for many years, as you see. Started in 94, 97. There was a proposed standard. 1998 was where the subpart R was written. Then there was some public hearings in 1998. In 1999, December 16th, OSHA convened a public meeting of CENRAC to consult with the committee on the agency's final draft rule. And this went on, and finally, January 18th of 2001 is where the current rules are. They were issued okay, for that safety standard. But then it's 6 months later before they actually go into effect from 2001. So July 18, 2001 is really what you are working under today. And I don't think that there's been any minor or major revisions with this rulemaking, though I think somewhere there's a period of time where OSHA has to come back and revisit the rule and see whether there are any changes that do need to be implemented beyond that. One of the issues that came out of this was one of the items in at least dealing with open web steel joist construction, come on in, there's still seats around, was with what we call column or tie joists. Okay, when a building is being erected, right, once that column is up, that column needs to be secure in two directions. And with joist construction, that was one of those questionable things that came out. We'll put the joist girder in one direction and a joist in the other direction, which we'll call a column or tie joist. What they wanted from SJI was to develop a joist that could be, that an erector could walk out on, unhook the hoisting cable without any bridging being provided for that joist. And we'll see, and I'll show you what happened in the research that came out of that. They put a moratorium on that for a short period of time, waiting for the results of the research that we did. But effectively, there is a permanent moratorium on that because we showed them that with all the uncertainties, with all the unknowns in dealing with joist and joist girder erection with the column joist, that we cannot always guarantee that that joist would be stable with an erector going out on that joist to release the hoisting cable. But as the world moves forward, I think most of the erection equipment that's now out there has solved the problem because now we have self-releasing hoists and hooks and things like that. So a lot of that I think is sort of gone away. This is just a breakdown if you are a general contractor or you have a copy of TD number 9. These are the chapters that we have in that technical digest. And I'll hit on a few of these as we go through the morning presentation. One of the things both with SJI, with AISC, with AISI, the American Iron and Steel Institute, was as we do our work, we all need to be talking a language that we all understand and we're not confused with. So we've provided now a glossary of terms in all of our documents, as well as SJI, as well as AISC and AISI. So we've started to make sure that when we define a term, it's used consistently through all the steel organizations. OSHA has some additional terms that they've defined and they're listed here, and I think you do have a copy of all these slides in your packet, so you can look at some of these definitions later. But they talk about anchored bridging, bolted diagonal bridging, bridging clips, bridging terminus point. A competent person, this is one that we do have to talk about just a minute. A competent person means one who is capable of identifying existing and predictable hazards in the surroundings or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has authorization to take prompt corrective measures to eliminate them. So how many of you are competent people? Okay, you meet that criteria. Because they'll also define another term later on we'll get to, which is a qualified person. OSHA defines constructability, which is sort of their out clause for things that, because of issues with constructability, that they give you exceptions to do. Construction loads they define for joist erection means any other load other than the weight of the employees and the joist and the bridging bundle. And here's the definition for a qualified person. Means one who by possession of a recognized degree, certificate, or professional standing, or who by extensive knowledge, training, and experience has successfully demonstrated the ability to solve or resolve problems related to the subject matter, the work, or the project. So how many of you are now qualified people? Okay, we have at least 1, 2. Okay, so you have to realize the terms that OSHA has now defined for you within the workings of the Code of Federal Regulations. They've defined steel joists, and to say, and I try and use the term that we talk about our standard specifications and our standard product. Right now, a steel joist is an open web product that is a secondary load-carrying member of 144 feet or less, designed by a joist manufacturer, used for the support of floors or roofs, and does not include the structural steel trusses or cold form joists, okay? Or probably that other material, wood, where we have wood joists. But the word joist now is sort of, everybody calls a joist a bar joist, and it sort of could be from the smallest joist, an 8K1, to the largest joist, which at our current time is a 72 DLH-19, okay? There's a wide range of product there that we can just call as a bar joist. And we also have our structural steel joist girders, which is the primary load-carrying member that the joist would be set upon. This is the 42nd edition catalog, and if you do work with joists and you need a copy of this catalog, you can download it for free from our website. There's a PDF that goes cover to cover. And these are the sections that are in that document. We're presently working through our engineering practice committee to put out our 43rd edition catalog, which will come out either the end of 2010 or the beginning of 2011. But with the IBC and the ICC, their schedule, we have to have all of our work done by the fall of 2010 to go into the next edition of IBC, which is the 2012 edition. And we are making some significant changes in it, probably adding more material in there in response to engineers. When we looked at our joist girders, okay, some slides want to go by themselves. Let's go back. Just a simple picture that shows joist. There's a column joist and joist girder, column, everything being framed together. The bridging is in place in that picture. And we'll see several more pictures in this presentation. Our K-series joists, which are our short span joists, are really what, if you're going to use the term bar joist, they range from an 8K1 to a 30K12. We are going to eliminate the 8K1s and take them out, because that is something that we find the manufacturers have decided that it's less cost effective to produce 8K1s than the other products. And there are a lot of reasons, so we decided not to have them as a standard product going forward. Standard seat depths for these products are 2.5 inches, span range is 8 to 60 feet, and our specifications like AISC, AISI, the material specifications now primarily are all dual specifications. They give you all the information you need in allowable stress or allowable strength design, as well as in load and resistance factor design. For the engineer, that's more important than for the erectors. But that's the way the tables are broken down. Our maximum span to depth ratio of our standard product goes up to 24. So if I have a 20-inch deep joist, it can have a maximum span of 40 feet. We also have KCS joists, which fall as a subset under the K-series specification. These are our constant shear, constant moment joists. Essentially, this series of joists came about for all those other loads other than just uniformly distributed loads. If I've got an RTU unit going up on a roof and the mechanical engineer doesn't know exactly where it's going to go, structural guy got to get his work done, and this whole thing's got to move forward. So this was literally an envelope of the worst condition for that product. So then that unit could actually be located later after the product has already been manufactured, delivered, shipped, directed to the site. That unit could then be placed. But again, the loads from that unit need to fall out at the panel points of the joist. Otherwise, we have to do some work with the joist. So as you see, the depth, the seat depth, the span range, maximum span to depth ratio all falls within the standard definition of a K-series joist. And because we don't know exactly where the concentrated loads are, all the web members in the joist are all designed either to be in compression or in tension. So it doesn't really matter where the placement of the load is. The long span joists and deep long spans are LH and DLH. As you see, they go from an 18 LH02 to a 72 DLH19. Everybody asks what those numbers are at the end of our designations, and those are just relative chord size numbers. Because we are probably the first performance-based specification, you're designing, or an engineer designs a joist, he's picking it out of a load table to carry a certain PLF loading. Okay? he gives that designation, puts it on a drawing that gets to a joist manufacturer. So if it says 18 LHO2 and there's a certain span for that joist, there's a certain load that it can carry. That's all done, the design and manufacture of that product is all done by the joist manufacturer, not by the engineer of record who's designing everything else. There you see the standard seat depths, either 5 inches or 7.5 inches for the largest. Span ranges, actually these go out to 144 feet. And there's the load carrying ranges for those, either 1068 PLF or for the LH joist or 706 PLF for the DLH joist. And if you're looking at the ASD numbers and the LRFD numbers, what we had to do was do a calibration to figure out how we got from one design methodology to the other, and that's a nice multiplier of 1.5, okay? Because it's really based on just it's carrying dead load and live load. If I've got some other load combination that is what is the critical load combination for the design of the joist, that sort of would change. But that would all be done by the joist manufacturer. Again, the span to depth ratio is 24, but now with the K-series joist, it is only a parallel chord product. Okay, the chords are supposed to be parallel chord, underslung joist, or could be bottom bearing joist or square-ended joist. With this series of joists, they can either be parallel chord, they can have a single pitch, they can have a double pitch, they can be underslung or bottom bearing. So the engineer could design the joist as any one of those shapes, if you will, and it would still fall under the standard specification of the LH-DLH series. Joist girders, which are the primary members for carrying load in our system, if you are thinking about, if you've done joists not that frequently and prior to 2005, these numbers have changed drastically, okay? The depths now go from 20 to 120 inches. Standard seat depths, still we keep it 7.5 inches. Spans now go from 20 feet to 120 feet. Loads, panel point loads go from either 28 kips or 56 kips. And when you look at the load table, it's not a load table, it's a weight table for the joist girders. We were giving the engineer what the PLF weights are of the product. As that product gets deeper, longer, then we started to see a drop off in the load carrying capacity of the product. So instead of having tables all built out to 56 kips, we started to see this drop off. So we said, okay, every one will at least carry 28 kips, but there are plenty of the smaller product that can carry up to 56 kips of panel point. If you recall, back in 2002, prior to this edition of the specs, that panel point loading was 20 kips. So we bumped that up pretty significantly. Weights of these joist girders can range anywhere from 15 PLF to 200 PLF. So you're looking at a pretty stout product at 200 pounds a linear foot when you think about that compared to your structural steel. Web configurations I'm not going to get into today, but there are 3 types of web configurations. It's really more important for the architect or the mechanical guy if he's trying to put stuff through the openings of the joist. That's really the benefit of any open web product. If you've got electrical conduit, you've got cable tray, you've got HVAC duct, you've got all your services, it can run through the openings of the joist, whereas if you're doing structural steel, unless you cut openings in a beam, then you've got to run all those services underneath. So when you look at what is the depth you're really taking up with your structural and your services can be a lot more than just that steel member, whereas with a joist girder system, assumingly everything is going through the openings. And this is how we designate a product. 48G, 8N, 9K. The 48 is the depth in inches. G is the configuration of the webbing of the product. 8N is the number of spaces, of joist spaces. Typically it would be where the reactions, the end reactions are of the joists on the joist girders. And the 9K is 9 kips. That's the panel point loading for that particular designation. And again, you can see our nice 1.5 multiplier. And we now change the K to an F for factored loads because in LRFD we're dealing with factored loads. When we look at the products itself and how they're typically constructed by the joist manufacturer, and again, this is an idea of when you're looking at a product. For the short spans, the K or KCS typically have rod webs But then we start getting into either a crimped angle web member, or one of our manufacturers uses a cold rolled channel. That's the thing, when somebody calls and says, well, I don't know what are the chord angles for that product, what are the web angles for that product, I say, I'm not sure. I can give you approximately what they are, but because it's a performance-based specification, we have 15 manufacturers, 15 member companies with 40 manufacturing facilities in North America. They all have their own designs for the joist to meet the load carrying capacities in the load tables. Okay? So it is a performance-based spec. So if you were to get the same joist designation from 5 different member companies and you laid them all side by side and they all had to carry 300 PLF, you would probably find that there are slight differences in the design of all of those products, but they would all work. If you have any questions as I'm going along, just raise your hand or just shout out. Of course, all of our member companies, and those of you who do some large erection probably have seen a lot of these type joists coming out of our member companies. These are some of the non-standard products. This is certainly not inclusive of everything that I've seen. They could be scissor joists, rainbows, bowstrings, gables. The top 2, though, if you are an erector and you're putting up that product, you need to know that as soon as that product gets set, it's going to have some thrust, because it's not just sitting as gravity load. There is some thrust that's going to be with that product, and that all needs to be resolved when you erect that product. This is a truck coming out of one of our manufacturers. So as you can see, what was on the last slide and what's on this slide is, if the architect can dream it up, the joist manufacturer can produce it, and it can be delivered to the site. But there will be specific rules on their joist placement plans for the erection bridging and the construction bridging, permanent bridging that we'll talk about. Yes, sir?
The previous slide where you got some of the different shapes, it says special conditions will be required. Does that show on the erection drawing? And if it doesn't, how does the erector know?
That has to all be written out on the joist placement plans, the erection plans with that product. Yes. Right. Right. And that also has to be within, if this started out with the engineer, he's got to know that there's a thrust based on the load condition for that product. Just a quick word about if you get involved in pre-erection meetings that deal with joists, some of coordination issues that might be in shipping schedules, site access, storage of the joist products, erection, make sure that the crane capacities and reach are all appropriate for the size of the joist product. Again, scheduling, erection sequence, availability of the materials, and field inspection, what type of inspection is going to happen. Today with the joist products, all of our manufacturers are required at least to put their name on the tags. There should be a metal tag on every joist on one end of the end web of the joist. That's typically where they place a metal tag on that, and that should not be removed. It's sort of like that tag you get on your sofa or on some of that other stuff, do not remove under penalty of law. I said we should probably put that on the tags, because everybody says, well, there's never a tag when I go out to look for one after the fact, so I don't know where all the tags are. Somebody must have a collection, like you collect old license plates, somebody's collecting tags. But most of the time it's just a piece mark number, so it really doesn't give the Institute a clear idea of what the joist is. And someone says, well, what if they just put the joist designation on the tag? Most of the time these joists are carrying loads other than just the uniformly distributed load. So there's always, one of the manufacturers says, you know, just about every joist we do now is somewhat a custom design, because there's a concentrated load that we have to verify that that particular web member, where the concentrated load, they may have to resize one web member in the joist to carry that additional load. So there's that kind of information really winds up in the calculation package that a joist manufacturer will produce and would sign and seal. But putting information, let's say, on a tag really is not getting us to where we need to go. Loading and shipping, typically, I used to see a lot of these trucks going down the road. I drove to Atlanta on Monday, I drove back on Wednesday. I did not see one of these trucks in my 700 miles of driving the other day, so a little disappointing. realizing most of it gets delivered on a flatbed truck, but every once in a while closed trailers or open top trailers are used. And I guess I should say is just if you are involved in breaking those bundles off of a truck, be very careful that if you break some of that banding, those joists seem to want to just pop open sometimes, so you really need to be careful when you do that. And that's probably what this slide says. Joists should be inspected when they arrive at the job site to make sure that there are no problems with the joist. It could be a third-party shipper, and when he cranked down on his metal chains and he bent the cord angles down, that maybe those need to be looked at and evaluated before you just say there's not a problem and you erect them and there is an issue with the product. I've seen a lot of cases where when they get them and they're coming out of the bundles and the ends of the angles get bent up. A lot of that is easily fixed in the field, but there are times where the joist manufacturer should be called out to the site to evaluate his product. It is a warranted product, okay? And if you do something to the product without the joist manufacturer's knowledge, guess who now owns the warranty? You own the warranty, okay? Receiving, unloading, storing. Typically, joists are unloaded with a forklift. I've seen most of the time now, not as often with a crane. It's pretty quick with a forklift, but you do need to be cognizant of when that guy is driving that forklift, how he's carrying the bundle. Not so good over here, right? He could be dragging that end real closely into the ground. What's wrong over here? Can you see this? Yeah, when he's just picking that up, he can adjust those forks, right? And if you're watching him, you know, you need to yell at him and tell him, don't stick it through that where the two webs come together, because as he's lifting up that bundle now, he could potentially break a weld there. So you need to look. This one is sitting right under the cord angles. You need to get this under the cord angles. And because this is all pushed over to one side here. Very easy not to cause a problem, but if you're not paying attention and everybody's just trying to get it done, a lot of times you cause problems. And then setting it down, it should be set on proper dunnage, okay, because you don't know if it's not being erected that day, if it's going to rain, you don't want that sitting in a puddle of water for a week, and then you call the joist manufacturer and say the joists are rusty. And is that okay? The joists are dip coated, okay? All joists come out of the joist manufacturer with a dip coating unless that was something that was not part of the contract. But typically, they all go into a dip tank. They come out of a dip tank. On good days, I used to kid the manufacturers, the joists finish drying going down the highway. Gray primer, 1 to 2 mils thick, so it's only a temporary provisional coating. Erecting of the joist products. This is probably where we'll spend most of our time today, and hopefully we'll get this all done. Everything is designed in accordance with our specifications, and within our specification also has words about handling and erection of the product, which are really the same words that are in the OSHA documents if you read them side by side. Products should be handled with greater care than a rolled structural beam, but I think all products should be handled with care, and we should just end it right there. Until they are correctly and completely installed, a joist product may be slightly more unstable than a structural steel member. If you look at it, it's a fairly narrow product, right? And even on those trucks, and I've seen them when they're picked up flat and they're bent like this, they shouldn't ever be bounced around like that, because eventually that can also cause problems too. Complete installation includes attachment of the joist products to supporting structural elements and the installation and anchorage of all required bridging or other bracing. That's when it's done. This is a joist girder, and now per OSHA, there's a vertical stabilizer plate here, and there's what we commonly call the OSHA hole, because if you're going to put a guying cable there, in in lieu of this, just to make sure this column is stable, then you could put a guiding cable through there. And this connection does not get welded unless on the drawings by the engineer of record it says, one, he may say weld after all the dead load is applied. Excuse me. I sort of like that phrase because I know where the erectors are once all the dead load's applied. You're on the next job. So we're trying to, if it's not really part of the design requirement, that should not be welded. Just some pictures. This do all sorts of fun things sometimes. I've got joist girders in this direction, I've got structural steel in this direction, and for some reason, the way this was designed, we got this really funky connection here. If I look at this, what's wrong with this picture? If you look right here, I've got a vertical stabilizer plate on the joist girder here. On the tie joist or column joist, there should have been a vertical stabilizer plate here too. What do we do in that case? Sure.
Whether that bottom part gets welded or not is a function of design.
Should be a function of the design.
It's going to carry load differently.
Yes.
Your call.
Yes.
Ultimately your call.
Hmm?
Something whether the architect puts it on the note or not.
If,
It starts with you.
no, it's not us. It's the architect engineer of record's call. It's not the erector's call to say, oh, I'm just about done, I'm getting ready to leave, and I should weld these up because,
I'm not talking about that. I'm talking about you as a supplier.
no,
It's a performance-based spec. You have to make that call.
no. All of our products are simply supported, okay? Unless they're being used to carry lateral loads, okay? The assumption is our products are to carry gravity loads only, okay? So if I weld this, I'm making a moment connection here and I'm now carrying load. That is the call of the architect engineer of record. Now, the joist manufacturer can design this as a moment connection. Then that would be all shown on the joist drawings and on the structural drawings what this moment connection and welding would be. Okay.
Because a lot of times they come back in and tell you they want them all welded no matter what.
Who?
Come back to the GC, come back, just because one gets welded, they want them all welded.
Yeah, but it shouldn't be the GC's call. If he just thinks it's a better connection, then he just now turn this, if this now wants to move laterally, he's now turned this, instead of this being the tension cord, the bottom cord, right, it wants to go like this. Now if I've got lateral load, now I've got compression here, and this was not designed probably for any compressive force. The GC should not do that. And then it should come from, it has to come from the architect engineer of record. And then it has to be part of the design from the joist manufacturer. Yes, sir.
I think what everybody's getting at this, we run into this as a function of the inspector or the GC. Thinks that's the way it should be, therefore it's better. The engineer just, he goes along with it.
Truthfully, what should be on the drawing, it should say do not weld.
It's a matter, I think it's a matter of education, and SJI can probably work.
Well, we
Don't think it's a better product welded, but it doesn't really need welded.
no, because the performance now of this joist girder is totally different, okay? Because it's now acting part of as maybe as a moment frame, and it was never designed to carry those kinds of forces.
Your simple strut joist, though, I think that's what
Right.
everybody's referring to.
Well, on the tie joist too. Yeah.
The inspector feels that way, the
No.
contractor feels that way, and
No.
the engineer, he's just gonna go along with them.
No.
So we end up going back with seals down and have to weld them up, and that's what I'm getting at. It's more education, more communication in the field,
Yeah.
to the industry.
Well,
at SGI.
we talk about it at every seminar about this connection, whether it's the joist girder or the column joist.
Terry, let's talk a little bit more about the tie joist.
Okay.
Um,
Probably.
You mentioned early on about the fact that we needed the joist to be stable enough to support a person. That's part of it, but that wasn't really the main reason we brought that up. I actually brought that up in Sinrai. That tie joist needs to be strong enough to act as a strut. And I know y'all went through tests and it decided it couldn't be done, but what do y'all do about when you have a job that requires a center roll bridging, ex-bridging? When you erect that joist at the column, what's your practice at? It clearly says that you can't release the crane until that bridging is in. But about the only thing I don't do is put two together. Are we really doing that, or what we had hoped for, what I hoped for with Senrite, was that we'd have a member there, a joist that would be stable enough, or do you brace every column? If you set that bay up, your tie joist works fine in tension. Your columns can't fall out. Where if you just got that one joist there that's not stable, what's to keep that bay from falling in? And I don't know, what's happening out there, but it's a potential place for an accident. Also, how many of y'all in here remember back when you did not have the requirement to bolt that tie joist? That was a big thing SJI did to another bolt there. Well, and then as you say, they had Senrite, they put the stabilizer plate at the bottom, not have somewhat to keep that joist from turning. But of course, if you prefab your bays, then you can kind of get past that.
Yeah, we'll talk about that too.
I just wanted to know people out there still putting that joist up as a potential.
Yeah, it is potential. I mean, that the column needs to be stable. And again, if you got a guy that take the column to ensure that stability, that's one way to do it. Erect them in tandem. This is the issues now that I know we've had conversations with SIA, and it's sort of, a lot of things have come up in SJI, but this is one of the issues that I've seen recently when I'm out in the field, that I'll have a vertical stabilizer plate on this column for this joist girder, but what happened to the guy who did this tilt-up wall? He left it off. I mean, the joist manufacturer gave you this bottom cord extension to go to a vertical stabilizer plate. And I'm not sure how we solve this problem. And like they say, the show has to go on and this gets put up, but these things should be noted, that there was something that was left out. I mean, I'm sure you don't stop the erection and say, I can't erect that because there's no vertical stabilizer plate there. But I did go back to the engineer who did this, to the joist manufacturer who did that. Here's a case that actually is in a building here in Myrtle Beach. This was actually a plate girder at the opening, and they put a stiffener and they actually dropped down a plate to take that joist girder. So they did the job properly on this for this opening. And again, there are plates, vertical stabilizer plates over here. They're putting in the tie joist here, and it goes in the middle of this beam, and there was a vertical stabilizer plate. And all the releases on this job were all done automatically, or the guy was just really good at doing it, so no one ever had to go out on that joist to release the hoisting cable. We're going to go through some slides fairly quickly because this goes step by step. You have all the words on all the slides that you can read them, but it literally, I will point out some of the highlights of what is in the Code of Federal Regulations. As my friend says, if you're out in the field, you better have read the law. He says, because you don't want to break the law, he says. So it starts out in 757A general, except as provided in paragraph A2 of this section where steel joists are used and columns are not framed in at least two directions with solid web structural steel members, a steel joist shall be field bolted at the column to provide lateral stability to the column during erection for the installation of this joist.
And does the situation I was explaining, does that really provide lateral stability?
Well, it says, when you see the video I show, I'll will maybe answer that or discuss it. A vertical stabilizer plate shall be provided on each column for steel joist. The plate shall be a minimum of 6 by 6 and shall extend at least 3 inches below the bottom chord of the joist with a 13/16 hole to provide an attachment point for guying or plumbing cables. So that's what it says. And it goes on about when you are allowed to release the hoisting cables. Again, it says where constructability does not allow a steel joist to be installed at the column, it gives you alternate means as defined. Again, there's that qualified person who gets to make that decision. Hoisting cable shall not be released until the seat at each end of the steel joist is field bolted and the joist is stabilized. Where steel joists at or near column span 60 feet or less, the joist shall be designed with sufficient strength to allow one employee to release the hoisting cable without the need for erection bridging. This was the clause that we could not meet. This was what was in the 2001. It's still there today. But this is, if you go into all the proceedings that followed 2001, finally in July 18th of 2004, the effective date of the enforcement of this section was extended indefinitely, okay, because we could not meet that in every instance of every joist. It was one of those things that you can say this is what you have to do, but I think we have found, the erectors have found, the equipment is such today that there are other ways to do this safely without an erector going out on that joist. This is some of the testing work that we did. We had a contract, a couple years contract at Bucknell University, and what we were looking at is, here's the joist, there's our erector, and we set the 2 posts at either side for an L/120 movement of the joist, which is, I don't think you want to go out there and have your joist moving that far. So literally he's got his safety harness on, he's actually hooked up to the crane in the laboratory. So he's going to slide out or coon out on the joist, and he's going to see whether he can do that without that joist moving far enough to hit either of those posts. So this was some of the research that we did. We'll look at the next slide. It's a little, when you get a lightweight graduate student, what you have to do is put a weight around his neck to get him up to 250 pounds. Yeah, this is how you play with. It doesn't take much. I mean, and his center of gravity is right there at the top chord of the joist. You know, and he's not even moving along the length of the joist. The ends are bolted down like they would normally be for at that point where he would be going out to release the hoisting cable. We want to see that again. Doesn't take much. I mean, the joist is very flexible in that direction. It's a little ride. So what did SJI do? And I've heard a lot of screaming about what SJI did over here. You've all seen these orange tags, right, in the field on the column joists. But personally, is my boss here? These should go away. Because it implies, if you've put up the column joist and it's got that tag on it and it says all this good stuff, and that joist that's 3 feet to either side of it that's being erected, it almost implies to me that that one's safe because it doesn't have a tag on it. Okay? And it's really, again, the education, the training of what's going on here, because you can read all of this that's on here. But it says that we could not satisfy that requirement of what OSHA tried to impose on the Steel Joist Institute. You know, we did our best efforts. We did about a 3-year research project at Bucknell University. It's all been published. And with all the parameters, all the variables, we could never guarantee for all the range of joists that we could meet that. So the manufacturers have this nice orange tag, and sometimes it's bilingual. Yes?
Would the SGI go so far as to say we looked at like a tilted panel, it didn't have a stabilizer plate?
Well, there should have been a stabilizer plate on that.
The stabilized plate and bolt column to a tilt-up panel.
Well, I think there was a connection at the top cord. There was a connection, I think, at the top cord.
Probably only a bearing.
Yeah, there was some bearing plate. And it's something that I know we've sat down with Sia, and I've got stuff on my desk that we need to get back in to talk about the mixed construction. Because in all of the OSHA regulation, it is steel on steel only. They did not step once, and most buildings have, there's structural steel, there's joist, there could be cold form steel, there could be masonry, concrete, timber. I mean, all of it comes together in a design. And if you don't look at it as a structure, a 3D structure, you haven't really looked at the full safety issues.
I think what
Yes, sir.
they're trying to say is maybe you should note it on the drawings that that should be installed before erection, because there's always a stabilizer plate that's supposed to go there, but it doesn't say to install before erection or
But
during erection.
it now becomes is whose drawings and whose responsibility. When you look at all the parties involved in the design of a project, typically the joist manufacturer may be a specialty manufacturer that was hired through the steel fabricator.
Right.
Okay, so in that case, and I don't know, he could have been also hired from the general contractor. So it could have been a list job that our manufacturers call it, where there's a broker involved. So there's so many ways that this all can get done. It really needed to be done with the structural engineer of record responsibility in his drawings.
Right, but see, usually the joist manufacturer
If we-
doesn't
if-
supply that. It's
No, we don't-
The fabricator
Right.
of steel that supplies it.
Right.
All I'm saying is, should there be a note on the drawing saying?
There should have been a note somewhere, but there should have either been an embed plate.
You're talking about on a joist drawing.
Yes.
The field
Should it just be a little note on there saying installed before erection?
Or at least make sure.
I mean, the joist manufacturer could do that, but I mean, he did his job by putting on the extension to go to the plate. I don't think I have the picture in here. I was on a job, maybe I do, and literally they were doing panelized construction. But even in panelized construction, if the panel contains the tie joist, I hate to say this, but I was there with the particular joist manufacturer who produced the joist for this project. We were in Las Vegas. The erector had a Sawzall. And guess what he was doing? Before, he was cutting off the extensions because he said, I don't need them because there was nothing on the columns. There were no stabilizer plates on the columns.
Perry, you're doing a great job of sidestepping this guy's question here, but what
I don't, it's not, the joist manufacturer could do it, but it's not our it wouldn't be our responsibility, I don't think.
is, we don't understand whether that plate is necessary to erect the joist
Right.
safely.
Because we always go, put them up there and it's never
But-
there, and then we'll get.
But there's one on the column.
Like it's one of the last things
Okay.
we do is put
Am-
that up there.
am I-
And if it's for erection, maybe it should be one of the first things we do.
Let me ask why, tell you why I said that, ask the question. We're in the process of updating the NIST and the SEA detailing manual. And one of the issues, we'd like to see at the SJI, say, we would recommend that it's non-ferrous surface. Because we know what to do in columns, and it's very clear. A non-ferrous surface, tilt-up panel wall, a masonry wall. We think that there should be some anchorage system there when you put a tie joist or a joist girder there. We know that you can't dictate that because you don't design that bearing surface.
Right.
We'd like to make that recommendation.
Well,
The detailing
I-
manual goes to.
as I said, the small group that we had, and we sat down with Sia at a meeting about a year ago, and because this was something, when I kept seeing it out in the field, I said, I think something's missing here, and I'm not sure how we get to correcting it. Some do, some don't. I mean, so I am looking at ways within our own house and how we can get that word out that that should be there. Because you have a vertical stabilizer that the steel fabricator put on that column, but yet when the other end of the joist has nothing. you know, and realizing that OSHA explicitly only did steel on steel and they left everything else out. But I think, yes, I mean,
It seemed like that would be for you to put the note like he's talking about.
our manufacturers could probably do that. But I'm not sure whether the SGI can dictate to the manufacturers what to do.
I'm understanding that these things are mostly there just for the erection, for the stabilization. And if we're putting them on after everything's erected, I mean.
Well, no, then it's,
Right.
no, it should be there on the wall. It should have been on that panel.
You know, erector note.
Right, it should have been on that panel.
If it's an accident because of that not being there, you better believe SJI's or the joist manufacturer will be named in that suit.
Mm-hmm.
So it seemed like a simple thing is putting a note on the drawing would help relieve y'all of some responsibility.
Yeah.
You can say, well,
Yep.
we told them it should be there.
Yep. Well, we sort of indicate, we provide the extension there right to the wall with nothing. So this is what you were talking about is, at least for joists at or near column lines that span 60 foot or more, the joist shall be set in tandem with all bridging installed unless an alternate method of erection which provides equivalent stability of the steel joist is designed by a qualified person and is included in the site-specific erection plan.
Perry, before you leave this, I just want to ask one last question. This fellow's asking a legitimate question. We've got a tilt wall building, we got a girder set, you ain't got the plate there.
Mm-hmm.
We're not gonna stop and put it on, we've already got the joist or the girder on the hook. We drop it in, everything gets tied in. Now the contractor says, well, there's supposed to be a vertical stabilizer plate there, you need to go back and put that in. Is that necessary?
I would probably say no.
No, I mean, that's strictly for erection purposes, is that
The
correct?
vertical stabilizer plate is there for the erection only. Unless it's going to be welded as part of a moment
Doesn't get
frame.
welded, it's really not necessary.
It's really not,
Anything
no,
after the
no,
erection process.
no. I would say no.
That's, all you guys who heard that have to climb up here and put that on, I'll be available, you'll buy me a pizza.
Sir,
What's happening is that, in my scenario, the plates are never there. So they're making it the erector issue when we get to that point. Give me an RFI, give me a change order. It's not our issue right here. If it's not needed, it's for erection purposes only, for stabilization of the joist, right? That's what we try to explain to these general contractors, but they just say, it's your problem, please submit an RFI. But we want to keep going on. We don't
Right,
want.
right.
They
It's-
missed it, we didn't miss it.
Right.
We know our job.
Right.
But this
Right.
is an issue, this is
Well,
causing a lot of delay
right.
for records and a lot of problems.
yeah. I am sure there are cases, though, on some tilt-up projects that there was an embed plate and there's either a piece of a WT or an angle or something coming out, okay? Very rarely, because no one has dictated, it's only what OSHA did on this side, which was steel on steel.
I think they really whipped out on.
Yeah, well, but then do you want to open up?
Masonry or concrete.
Right, right. All right. I understand, and it's my concern too. I mean, I've seen it. So we just have to figure out how we get from where we are today to make sure that the erection of the product is still safely done. Okay. All right, OSHA goes on, and pretty much the same thing here about the girders. And when the joists are landed on a structure, they shall be secured to prevent unintentional displacement prior to installation. Again, that's really more, I look at that as at the end of the day, you know, when you've got product up there and it's not all been even temporarily secured, you need to make sure, because you don't know whether tomorrow's going to be a cold and windy day like yesterday out on the golf course. You know, the balls are going this way. The joists are just setting up there. Everything needs to be secured. Okay, you don't want to come back the next day and find all that product on the ground. No modification that affects the strength of a steel joist or joist girder shall be made without the approval of the project structural engineer of record. And I always add to that, and the joist manufacturer, because it is a warranted product. Don't go doing any cutting, repairing that you think you can just do and move on. There's a whole set of field bolted joists, and we consider that the final connection for the joist shall be the welded connection. Okay? Bolts for erection only, okay? The final connection should be welded, okay?
And is that not an engineer's job, but
That should be a manufacturer's job.
Again, we're right at that gray area of the end anchorage of the joist. I mean, we have it in our spec, whether it really belongs in our spec right now, but we say that that end connection shall be, that final connection shall be welded. And that's what we say right on that slide, right? Just go back at the bottom. The SGI considers these bolts temporary erection bolts and that the final connection must be made by welding or as specified by the project structural engineer of record. But why should he essentially supersede what we've done unless you go out there and say, well, we've got them all bolted, isn't that good enough? Why do I need to go back and weld them? Okay. OSHA defines the term bay, or uses the term bay but doesn't define it. What we've done is we've defined it for them. And these are our bay length drawings. This is what we would call, if I'm doing a joist on structural steel or on a joist girder, I'm going from center line to center line is the bay length. If I'm on masonry or concrete, the bay length is from inside face to inside face. And then when we talk about what is the minimum bearing, we're a certain distance in from that minimum bearing. And steel joists and joist girders shall not be used as anchorage points for fall arrest systems unless written approval to do so is obtained from a qualified person. I think that also gets back into the joist manufacturer, that really most would say that never should be done. Attachments, again, now we're talking about attaching to the structure. Yes, sir.
Are you saying that the joist manufacturers don't think that an iron worker should ever tie off to their joists or girders?
No, they shouldn't install the fall arrest system. If you're putting a fall arrest system, you should not be attaching that to the top chord of a joist, okay?
Really? Like
What about a joist girder?
A joist girder, you probably yes, would be fine.
Was it yes
But
or no?
joist girder or a joist?
Either.
I would say without that written consent from the joist manufacturer, I wouldn't do it.
So you're saying even a harness and a simple lanyard?
No, that's different. This is like a whole fall arrest system where you're putting up all the cabling and things.
That harness and that lanyard on where it is my fall arrest system.
And
And you're telling me I can't tie off to that joist?
no, this says a fall arrest system. I think we're talking about, that's a personal, isn't that called a personal?
Now, a fall arrest system is a harness and a lanyard. It starts out that basic.
Let's go back.
It starts out that basic. And then it goes
Well,
like a 3/8 rope tied to the top of the girder.
well, if I said I didn't write this language, this is what OSHA says. Okay, so now it's the interpretation of what OSHA meant when they wrote fall arrest system. Okay, I'm thinking it's not that personal system, one person tying off at one spot, but building a whole, you know, where I'm hanging nets and things like that is what I think that they were implying. Okay.
That needs to be more specific then.
Right. Eddie's going to make a note of that. Okay. Because this has to go back to OSHA.
Contradicted that earlier.
Well, it's joist. Okay. Well, when you're talking about a personal, with you've got a harness on and you just connect on, I think it's different than what they were implying by what they meant by.
Trouble if we try and determine what OSHA's implying.
Like I said, this was written in 2001. It's been there, okay? And I don't know whether there is any commentary on what this section says. I'm just going through what the law says, okay? First to know what the law says, and then we have to figure out, are we the ones responsible to interpret it, and what did they mean? But I really think they were thinking about, let's say, a whole floor where they're hanging nets, things like that, and that's all being attached. And that's not what they were looking at when this was written.
It would be interesting how many OSHA interpretations have been made off that from one district to another.
Yeah.
Yeah, they'll never agree on it.
It also has a qualified person statement.
Yeah, yeah, there's that qualified person. Where was the people that raised their hand that's qualified people? All right, when we attach to joists and joist girders, this again defines, yes, sir?
We should just use structural steel and everything.
No, I'm not saying that. All the AISC people are sitting over there. I don't think so.
At least for the tab member.
That's okay.
I didn't put them up for that.
I'll take my hits. All right, and again, here's that minimum definition for that connection of the joist. And again, this says really just for that gravity loading that came out of our load table. If I've got any other load combination that define the design of that product, then the engineer of record really needs to make sure that there is sufficient weld at the end of the joist to hold it in place. If there is a net uplift on the building, okay, now I've got a whole different condition that I've got to design those welds for to make sure that that joist stays in place if there is an uplift. And this is the definition of the end connections for the LH and DLH joists. And again, it says when that connection shall be made, okay, in this section. We're running out of time quick. OSHA does give you an option for doing panelized, and I think I have some pictures here of different, how many people have done panelized erection from small to large? It's one thing to consider. Here's a case where I've got a whole frame that's lifting an entire bay of joists, and the bridging is installed in the joists. Again, landing and placing loads of what loads can be placed on the joist is in this section, and it talks about only those construction loads that OSHA defined as construction loads, which is the bridging and the deck bundles and the weight of the employees that use that term. And everything needs to be secured and anchored before those loads get up there. It defines the weight of a bridging bundle not to exceed 1,000 pounds. And it also says that when that bridging bundle is placed, it shall span at least a minimum of 3 joists. I hope that the joists are also secured at that time when that's placed. Then it talks about the bundles of decking and where they need to be placed, okay? And this is one of the things that we're looking at now as I'm placing multiple bundles of deck that I'm not stacking them, but I then may place the first one a foot away from the end, but the second bundle may actually be inside. So making sure we've looked at what the loadings are during that construction. And this whole section goes through about the landing of decking and the placement of those deck bundles. Deck bundles cannot exceed 4,000 pounds. And they should be placed within, again, 1 foot of the end of the joist. But if you're placing multiple bundles, maybe that's not always the case. The second bundle will be inside the first. Yes, sir.
Now, I was just reading a couple back here, it said that this one's
Stop me or one
right
fold.
there.
Okay.
One row decking will be placed on steel joists until all bridging, and then on the next one it says 1 row. Which one is it? Go to the next one ahead.
In the other direction?
No, you were there, you just came off of it.
Okay.
That says all bridging installed, right?
Right. Unless all of the following conditions are met, and then that goes on. That's just the first condition. And these are conditions 2, 3, 4, 5, and 6.
At least 1 row of bridging installed.
Right, right. Okay. So these are all the conditions. Okay.
So then you can do either or, I guess.
As long as you, yeah, unless all of those conditions are met. If all of those conditions are met, you can do something different. Inspection of joist products. Field inspection is strongly recommended that the joist products be inspected prior to erection. When this is done, any questions that may arise can be answered expeditiously without affecting job site progress. And I just have some things in here. I'm going to skip through these about the inspection of the joist products after erection. And these are some of the things that we look at. And one of the things that I keep getting calls about are, and as you see, the joists are fairly flexible until they're in place. And in most situations, the joists are horizontal, hanging vertical. The joist shall be erected plumb and true. Well, if the joist has a sweep in it, when you're installing the bridging, your job is not to lock in that sweep. Your job is to pull that sweep out and then weld the bridging to the joist. So when you're done, that joist should be plumb and true. We have no other quantitative terms but plumb and true. Okay? So, and we'll see a picture later on of, and I got this call yesterday. Here's some more inspection questions. If you're doing the inspection, these are some of the things that you could ask or check off. Panelized erection again. Here's one where the joists are actually attached to the joist girders and the bridging is installed. Here's one where the joists are there and the deck is already installed in the panel. And then on the one on the right is a smaller panel that's being done just from a lull. Joist bridging, we have a whole section of bridging. There are 3 types of bridging, if you will, or at least we break it down into 3 types. We've got our erection bridging or erection stability bridging, which is either the bolted diagonal bridging or bolted cross bridging. Horizontal bridging, and this is all spelled out depending on the type of joist, okay, and the span of the joist. Our load tables are colored that if you are looking at a K-series load table, whatever is pink shaded requires erection stability bridging. If I'm looking at my long span, it's either going to be blue shaded or gray shaded. Once we get over 60 feet, then we need 2 rows at about the 3rd points. But when you have the bolted diagonal bridging, that means that the joist manufacturer has to put in bridging clips that are installed in his facility. That locks in where that row of bridging is going to be. With the horizontal bridging, you have some flexibility in being able to move it. We also have uplift bridging if there is a net uplift condition. That's typically those 2 rows of bridging at the first bottom chord panel points that may be provided. Section C of the OSHA talks about the erection of the joists. And these are tables that are directly out of really the same thing as what our specs say. You'll note that there's some line throughs and corrections of where what OSHA printed has some typos. I don't know how to get OSHA to fix a typo. I've asked my cousin who's a lawyer and writes legislation, and it's just amazing that you can't get something that you can go on the web and pull that off, but it doesn't have the corrections on it. This is our ASD load table for K-series. Again, there's the erection bridging for the long spans. And again, you see some corrections over on that table. And our load table, and you can see that shading. And again, we talk about when joists are over 60 feet, we need 2 rows of erection stability bridging before the hoisting cables are released. And we go on in section C. And finally, the permanent bridging. All bridging needs to have a permanent anchorage to a wall, to a beam, to a column. I was in a building in Atlanta the other day that, first off, the bridging was rebar. Not sure that was SGI called for. And the bridging was just sort of laid in, never attached to anything. But for the bridging to function properly, okay? And literally it's there for several reasons. Top chord for erection to provide that compression chord, this lateral stability. Once a metal deck is down, one could argue that that bridging may or may not need to still be there. I consider it joist girder, bridging as a system that is there for the life of the building. If we ever need to re-roof the building and they need to take the cover off and that bridging has been removed, somebody better look, and I'll tell the engineers about that. I know we're out of time, right?
Yeah,
Let me just skip to the end here. Just some quick things. This is a joist that is not part of 757 but erected under 756. It's a 210-foot joist. Okay. One of the things that comes up time and again, just give me 5 minutes more. They don't seem to want to rush out of here and eat lunch. splice here, splice here, splice here, splice here. The joists are built maybe as a continuous piece in the shop. They are then cut. They are match marked, okay? So you have to be careful when you are erecting these that all the pieces have to be turned in the right direction, and the 1A and the 1B, or however they're numbered and marked, all need to be matched in the field. Because most of the time when the joist manufacturer comes out to the field, these pieces have been put together in, and you can't swap this one for this one, because even though they look exactly the same, there may be some slight differences in the design. So keep that in mind, and then we're just going to go right to the end. A little bit on composite. We do have a composite joist system now, headed shear studs. This will be coming. Putting down deck, it's just a matter of getting the shear studs down onto that joist cord angle. Again, the same construction. It's this building that we saw going up is one building. It's all composite joists. Here's another composite joist system being made. Kohl's uses it for their mezzanine floors. Here's the construction of a mezzanine floor of a Kohl's that's composite. Another building, all composite joist. And again, you can see and some do's and don'ts. You should probably read through the list. This was a don't. This is one after. This was a refrigerated building. And of course, the building leaked. Okay? And they took the roof cover off of it. The joists were installed backwards in some cases, in the wrong places in some cases. It's amazing what can go on. I don't think we should install joists that are, there's the bolt. I don't think we even got a weld down there. So I'm not sure whether I could say constructability did not allow me to weld that. This is an interesting one. What happened was this end web is cut right here. Took 3 years for an overload on the roof for this to be noticed. But somebody just said, well, I ran into this wall and we fixed it. Here's one, don't put up the deck until everything is secured. This is the way it was. They came back the next day. This is the way it was. Thank goodness no one got hurt. Don't erect joists that have been damaged by improper chaining on a flatbed truck. Here's one that should have been pointed out and fixed and not just gone on with. Don't erect joists that have been run over by a dump truck. There you can see where he ran right over it with his tires. This is one where the erector decided, because he had an interference, so he just decided to just put in some more vertical members and fix it. Here's one, this joist girder didn't fit, so this guy is just taking his trusty tool and grinding it out so it'll fit to this connection plate right here. And the engineer of record, the joist manufacturer engineer of record was standing there with me when we took this picture. And he said, what are you doing? If the seats don't fit, just don't weld the nuts to the underside and call it a day. Don't put the bridging midway between the top cord and bottom cord. I guess you could get away with half the bridging if you just put it all right in the middle. This is what I was talking about, pulling the sweep out or locking in all the sweep and all the joists. Was done on a project. And now all the deck is down. Sorry I was a little lengthy, but I hope you got something out of it. I appreciate your attention, your patience.
Thank you.
You're welcome.